Subscribe to this YouTube channel by clicking the subscription button below. For future webinars and online short courses, please visit our website at australianwaterschool.com.au. Welcome to today's weekly webinar put on by the Australian Water School. Today we're going to be talking about emerging water contaminants. Dr. Anu Kumar is going to help us untangle the science. So glad for that. My name's Trevor Pillar, National Partnerships Manager here at iSwarm, and you are in great number today. Thank you. Through Asia and Australia, you can see there, Africa, scattering across the US, North America and South America. Coming up, you can see a plethora of free webinars between now and December, and they're, I think, weekly, pretty mostly weekly, on all sorts of important water management topics. We're keen to have innovative and game-changing aspects highlighted by these webinars, and some online courses there and face-to-face courses. Please do come on our website and join us for those events. I'm going to introduce Dr. Anu Kumar. She's a Principal Research Scientist in CSIRO's Land and Water Business Unit. And I'll skip some, you can read some of that yourself, but are you there, Anu? Yes, she's coming on now. Great to see you. How are you?
Thank you. I'm good.
Yep,
thanks,
you're looking well, looking well. I've been delighted to hear Anu speak on a number of occasions and more than engaging, hitting the main issues of this very critical issue of endocrine disruptor chemicals. She's a water quality expert with over 23 years experience tracking, identifying pollutants and developing robust monitoring systems. Anu is leading more recently water quality related projects in India and Myanmar. I'm interested to see down there workshops for rural women and children on safe aquaculture and safe use of pesticide. That is a fantastic part of this bigger work that you're doing, Anu, and a strong interest in applying scientific knowledge and innovative solutions. I don't see why we have science if we don't have innovative solutions coming out, but it's a pleasure, and we are feeling very privileged to have you speak with us today. Thank you for taking the time to do this. But over to you completely. Thank you.
Yeah.
Anu.
Thanks, Trevor. Thank you very much. And thank you for joining this webinar. And as I said, we will be learning from each other. Working on emerging contaminants, and I'll focus on aquatic environment for this webinar. So when it comes to emerging contaminants, it's just very overwhelming. If you look at, there are greater than 120 million chemicals, and there are still more that are ready to be registered. And I think in 2014, more substances were added than over the last between 30 years until 1990s. And I would like to say also 500 new chemicals will be added by the time I finish this webinar. So emerging contaminants, I think it will be good to clarify that definition. So it's defined as any synthetic or naturally occurring chemical or any microorganism that is not commonly monitored in the environment, but has the potential to enter the environment and cause known or suspected adverse effects, both ecologically and also from human health perspective. So I think because it's such a broad topic and there is so much that we can share and discuss. So just to keep it focused, I thought I will try to just share our experiences and what's happening globally in the space of endocrine disrupting chemicals. And I'll be talking from environmental impacts aspect, both in terms of regulations or the approaches, tools that are available. And my expertise is not in the human health, but if you're interested, I can definitely guide you to some of the documents and the other key experts who would be able to guide you and provide further information. So to start my webinar, I'll just provide a very quick update on EDCs, endocrine disrupting chemicals. They are also called as endocrine-active substances or endocrine modulators. Then I'll be talking about some of the approaches that are being currently used in Australia and other countries. I'll give you some examples from Australia, and I'll talk briefly about a project that I'm leading in India and talk about some of the challenges and future directions to fill in the gap in relation to endocrine disrupting chemicals, Sagar. So, okay, when it comes to the definition of endocrine disrupting chemicals, I think it's good to go with the WHO definition. It's an exogenous substance or mixture that alters functions of endocrine system and that results in adverse health effects either in the organism that is intact or its progeny or subpopulations. And I think although the issue of EDCs has been around for a while, but it's over the last 2 decades, there has been growing scientific concern, public debate over the adverse effects that may result from exposure to these EDCs, and that could lead into disrupting the normal endocrine system in wildlife and humans. And if we look at the class of these EDCs, it's not only restricted to persistent organic pollutants, as we call them, POPs. And only a very small fraction of EDCs in the environment are currently understood, and there's a lot that needs to be done. So just for the beginners who have not worked in this EDC space, I think this will help you to know that they can be natural synthetic compounds. It is androgen if it's related to male sex hormones, estrogens when related to female sex hormones, like it can mimic, the classic example is contraceptive pill. Ethinyl estradiol. There are also certain pesticides like chlorpyrifos, if you can relate to that, metals like even mercury is there, but also for some of you who are working in looking at the impact of fluoride, especially in the developing world in groundwater, even fluoride has been shown to have endocrine potential, especially in relation to diabetes and also when it comes to thyroid disruption. And then there are a list of pharmaceuticals and personal care products. Industrial chemicals, we know about bisphenol A, but even the substitutes of bisphenol A, nonylphenol, dioxins, PCBs, and even the hormones that are present in plant, like phytoestrogens, like soy, they also have endocrine potential. And when we look at the sources, they can be from domestic industrial wastewater effluents, urban agriculture runoff, livestock, mining activities, landfills, even stormwater. So just wanted to share this information, and this is a recent article like a couple of years ago. I think it's essential. From a human health perspective, there have been studies done on these chemical classes, and especially with the flame retardants, there is intellectual disability, organophosphate pesticide, intellectual disability, phthalates have been there for a long time, bisphenol A, and the general outcome is that this study was done in the UK and in the US, and if we look for each classes of these chemicals, there are a large number of cases that have been reported in the US and in Europe. And here are some figures in the last column about the annual cost in terms of managing these diseases. So you can see that it's a really a big issue from human health perspective, and our environmental contamination or the classes of chemicals play a significant role also in relation to resulting in these human diseases. And yeah, from Australian perspective, I think there is a lot that has been done in the US and in Europe. And there is always this question being asked, why do we need to address this issue, let's say in Australia and even other countries like in India, Indonesia, or Myanmar? The main thing is that we have unique flora and fauna. And the other thing is because of that, we need to protect our biodiversity, and also in relation to some of these emerging contaminants like EDCs, we lack national water quality guidelines. And we need to remember from aquatic environment perspective, fisheries is really an important economic resource, both in the developed world and even in the developing world. And we need to protect these resources. But also, I think from Australian perspective, there is also, we need to be able to drive water demand reduction and water reuse, especially you have heard like when recycled water for indirect potable reuse was first proposed in Sunshine Coast in Queensland in 1990s, there were concerns raised in the local community about the safety of the water and regarding endocrine disruptors present in the drinking water or in the environment. So I think from water cycling initiatives also under drought conditions, it is critical that we understand our own backyard and try to come up with tools and approaches to be able to monitor and to make sure that we protect our ecosystem and also human health in this from these chemicals. So I think the endocrinology, I saw that toxicology was picked up as one of the area as in terms of requiring more information. So I think the main thing is that the general toxicology, if you look at these glasses, we see the concentration as it decreases, and we know that the chances of diseases and the impact on the fauna would be reduced. But with the endocrinology aspect, I think we find that it's not always the dose response relationship is not definitive, and there are no defined safety threshold, and the effects are seen at very low concentrations like nanogram per liter, and these are because of the physiological changes happening at molecular level leading to changes at an organ and organism level. I'll touch base that again. So this is the reason the approaches that we have been using in ecotoxicology or toxicology in general are not applicable when we address these chemicals which have specific mode of action. So I'll be now touching base on the regulatory aspect, and I think it is important. I've worked in another industry, and we did a survey, and we asked this question, like, what would help to improve, the management of contaminants in the environment, and the topmost that was registered by these survey questions was the regulations. So I think regulations play a key role in providing us with the safe water and also making sure that our food sources are also safe. So I'll be touching base on some of the regulatory aspects in EU, US, Japan, China, and also from Australian perspective. Next slide, please. So I think when it comes to endocrine disrupting chemical as a mode of action, Europe is ahead of the game. And I've highlighted this text where they say that they have amended their regulations and to determine, the endocrine potential properties, and they have come up with a set of criteria for that, both from human health perspective and also from ecosystem health perspective. Next slide, please. And this is quite recent. It happened only in So they talk about like there has to be a criteria, and the effects should be shown on non-target organisms, and it should have adverse effects at a subpopulation level, and it could be change in morphology, physiology, growth, development, reproduction, lifespan. That are some of the indicators that need to be looked into, and basically there should be an adverse effect as a consequence of endocrine mode of action. So this has been even used for plant protection products regulation in EU. And so in EU, they have got a list of these endocrine disruptors and in category 1 substances where they could establish clear evidence of endocrine disrupting activity. There are 66 chemicals listed, and there are 564 chemicals. They have been, based on published papers and reports, are being suspected as endocrine disruptors. And then for the category 1, there were 3 categories that were defined as high concern, medium concern, and low concern. High concern is expected due to environmental concentrations, those in food and consumer products, and from wildlife aspect also, due to the emission or use patterns, or the chemical is persistent and bioaccumulative. Similarly, for the medium concern, human exposure is not as expected, and wildlife exposure is expected due to the emissions, but the chemical is biodegradable and not bioaccumulative. And low concern when there is no human exposure and no wildlife exposure. So I think talking about, I did touch based on POPs, persistent organic contaminants. So even the emerging contaminants such as per and polyfluoroalkyl substances like PFAS and some of the surfactants that are phenolic chemicals as hydraulic fracking chemicals are also presenting new challenges, and those discussions are currently happening. So in the US, they have come up with a two-tiered approach to screen pesticides, chemicals, and environmental contaminants for their potential effect on estrogen, androgen, and thyroid hormone system. So they have initially selected under the endocrine disruptor screening program just 3 these mode of action, and it is subdivided into tier 1 and tier 2. And there's a lot of information available, and please get in touch with Trevor and the team here, and I'll be happy to share further these documents. And there is a web link provided in case you need further information. The tier 2 assessment is much more advanced and involves toxicological testing, where there is a greater level of effects as chronic or sublethal effects. So Japan, I had an opportunity to work with the Japanese Ministry of Environment, and there is a UK-Japan endocrine special interest group, and I have been representing Australia in that group. And they have been quite active since 1998, and they have prioritized 67 chemicals, but they are also leading another program, Extend. So it is on extended task on endocrine disruption, and so that they can develop these methodologies of assessment to assess the environmental risk of EDCs and take management measures if necessary. Next slide, please. So when we look in China, and I think it will be very relevant to other developing nations, there is no dedicated regulation focusing on endocrine disruptors in China. Although the government plans to organize a national survey on the production and use of these disruptors, and the government would like to take measures to restrict these chemicals, and including industrial and the pesticides that have endocrine disruption potential. But I think, as it would be for other countries like India and Myanmar, Indonesia, I think it will be all based on what's happening in this space in the US, in EU, in Japan, and the criteria will be based on the regulatory framework that are coming up, are being established, and the conceptual frameworks that are coming from OECD. And I think, so these are this is the information from regulatory perspective. But I would like to say that if we look at what is happening in terms of the research or the science direction, I think the researchers are quite active. If we look at the sewage wastewater treatment plants, they are taking initiatives. So water industry is quite active in this space, including Australia, where they have taken initiatives to understand what are being discharged into the environment. Is there an endocrine potential? So although the regulatory framework are still not there, but I think the science is still there. And there is a lot of work that is happening currently. NZEC guidelines. Okay, when we look for some of the emerging contaminants or that have endocrine potential, then there are indicative water quality guidelines for nonylphenol phthalates, chlorpyrifos, some of these surfactants, diuran, glyphosate are also listed there. But when it comes to the guidelines are being, they have been revised, and there is a lot of interest in having endocrine disrupting chemicals also to be included in that guideline framework, and the discussions are happening, and I think there will be more that we would see in the space. But when it comes to the testing of the effluents, suppose if I take it as an example, wastewater treatment plant effluents, then every state or every major water utility has taken up initiatives to learn about, to basically know what their system is and what kind of these chemicals are being discharged. So they have conducted their own monitoring studies to have that evidence and knowledge, and to come up to speed with the other developed world, and be ready when the regulatory frameworks are being implemented. Next slide,
So
please.
what do you think, Anu? Is this a good moment to have a little look at some of the questions coming through as we go? Yeah, is that a good time? You've done the regulatory part of it. We're about halfway through entire time-wise. We're half an hour in. We're going for a full hour. So we will definitely do the full hour today. There's just so much in this, and thank you for the amount of effort that's gone into this.
Sure.
So first question, there is, given the large number of EDC chemicals, it would be impossible for any organisation to monitor all of them.
Yeah.
What guidelines exist to screen them in terms of those causing the highest risk and consequences?
Great question. And I think when I talk about the approaches and tools, there would be, like I will provide more information, but there are tools and approaches, like just the targeted chemical analysis is one of the approaches for monitoring and understanding these chemicals. But there are other bioanalytical in vitro methods that are available that can collectively measure the endocrine response and look at different modes of action. So there is a solution for that.
Well, as you say, there's probably a lot more could be said there. And by all means, everyone, keep the conversation happening. We'll have to moderate, that's for sure. The second one there, you might be able to see, everybody can see, without monitoring long-term effects, how confident are the experts that the classification of EDCs prioritised for monitoring is a robust classification? How confident?
Okay. I think the more, so it's based on weight of evidence approach. So basically the weight of evidence approach is, and you start with the tier assessment. So it's a very complex question, but I think there is enough planning in coming up with the frameworks, with the key experts globally. I think there has been a lot of thinking through, especially for endocrine disrupting chemicals. So I think we are there. We know, but the thing is that there are different modes of action, and I'll talk about that again. The question is being asked in relation to, like as I said, the focus is on estrogen, androgen, and thyroid, but there are other modes of action, and that's also prevalent in the rivers because of the discharges of chemicals or effluents. So
that question about robustness is will keep coming up, I'm sure. Professor Ramesh Purohit in Udaipur has asked, do I plan to work in Udaipur for the Aha River
Very
pollution?
much. As you know, CSIRO has been quite active and has done some work on our river pollution, and Dr.
Yep.
Raikukna from our group
Yep.
has done some work. But I think when it comes to using these kind of bioanalytical approaches, effects in terms of looking at the toxicity, I would be very keen. I'm ready. You tell me when should we start this program.
That's the reason this webinar happened so well, Anu. Thank you for your total commitment to this, and really, it's fantastic. Look, well, let's keep going with this presentation. Sure. We're about third way through this presentation, but we're definitely only got 30 minutes left, so might have to speed up a little bit. But that's good. All right, over to you.
So I'll speed up as and there are opportunities to discuss this further. So in Australia, as I said, the group of researchers 10 years ago came up with the Black Mountain Declaration, and there were even key experts, academics, water utilities, and some of the government policymakers were also associated with this declaration. That happened in 2008, and we decided that yes, we need to understand these EDCs coming from wastewater treatment plants, we need to understand the other sources, and we need to come up with the method so that it's based on our indigenous fish populations rather than the data that is coming from overseas, which is on fathead minnows and medaka and zebrafish. So we have used some of these tools and approaches. So I think when it comes to the endocrine disruption, there is a risk management framework that was established. So the question is, what might happen? So in case of endocrine disrupting chemical, there could be reproductive impairment, likelihood of happening if we are discharging this effluent, and if we have not monitored, or so far if we have monitored and we are picking up these chemicals, then the probability is there that there could be ecosystem health effects. Consequences of happening, if these we have done some modeling work along with the UK Brunel University professor Sue Jobling, and again it's published work where we said that the situation in terms of the discharges or the concentrations are quite similar. And I think if we are looking at the climate changes as the drought conditions, then there could be, some scenarios where there could be long-term effects. And the other thing is that traditional direct toxicity assessment approaches have limitations, and they do not work in this case. And I can see one question, which is about the National Water Quality Management Strategy Guidelines on water recycling. And phase 1, 2006, I do agree that the EDCs are mentioned there. And the framework to use has been also been listed. But when it comes to what to measure, when to measure, what are the criteria, that sort of information is lacking, and we haven't done any systematic kind of a monitoring program as yet. So Glenn Neal, I think that's the question that I was responding to. Okay, so when it comes to the biological effects of EDCs on aquatic biota, we did a study in 2007. This report is available. Then we followed up with another report in 2012, which was funded by National Water Commission. And we did include some of the studies. We include European carp, because carp is something that is available everywhere, all around the world, Cyprinus carpio. The only thing is that it would be good to use Cyprinus carpio for looking at monitoring or understanding the bioaccumulation of these contaminants in carp. But when it comes to the endocrine responses, we found that the sensitivity of this fish, based on some of the cell line reporter gene assays and comparing different fish species, we found the response was low. But there is a lot that has been done and I do not have time to share that information, but I just wanted to let you know that there is information if you want to know more, and we can share those reports with you. Okay, so I'll talk about some of the approaches to assess endocrine disrupting chemicals and this will answer the question about, there are so many chemicals. So I'm not talking about the targeted chemical analysis approach. As it was mentioned, there are hundreds of thousands of chemicals, and we really don't understand, and we can't measure them all. Their detection limit would be low, or we don't know at what concentration would they be, demonstrating that endocrine potential. So I'll go through some of these approaches. Next slide, please. So this is the again draft guideline implemented on hazard-based criteria to identify EDs in Europe, and they said that there should be endocrine mode of action, and there should be adverse effect, but there should be some kind sort of a the linkage between the two. So for ecotoxicology, demonstration of adversity at the population level, that the impact is there on reproductive performance is being, this is a requirement based on the current approaches, which are hazard-based criteria for endocrine disrupting chemicals. So I think when we look at endocrine disruption, if we look at the hormones present in a human being and in the fish, we find that they are very similar. So you will find pituitary, liver, ovaries, testes, similar architecture of the HPG axis, but there are some differences in the structure of some of the steroid hormones. E2 is E2, but when we look at dihydrotestosterone, it is in the fish, it is 11 ketosterone. So there are, although the assays, the tools that are available, if we are looking from protecting the ecosystem health, then we need to have certain tools or assays that would be just fit for fish because of subtle differences. So monitoring of environmental EDCs can be done by these in vitro receptor assays, and they are quite powerful in terms of picking up these contaminants at very low concentrations. So basically what you do is you collect a sample from any creek or river where you think there could be a potential of these chemicals present. You collect them, but how you collect them, there are certain procedures and protocols you need to follow. For an example, like you can't be using perfumes or sunscreens and no smoking. So there are a list of these guidance that are provided and part of the protocols when you're collecting these samples. And then because these can demonstrate endocrine potential at very low concentrations, so what you do is on the left hand side, after that collecting the sample, you see a picture of solid phase extraction where samples are being pre-concentrated, and then they are eluted, and based on the elution you collect an extract, and then you run them through these bioanalytical assays. And these bioanalytical assays actually are in vitro assays, and they are quite powerful in detecting activity. So they provide actually some measure of the bioactive chemicals that could be present in a sample. So if there is an estrogen activity we want to look at, then all the chemicals that could be contributing to the estrogen activity could be measured by in vitro screen, and that is the advantage that you do not need to analyze them by one by one, these chemicals. And also they provide, because so there are a number of assays that are available. Certainly they are not the perfect methods and will not but they are quite a powerful tool as a screening tool, as a tier 1 assessment. In OECD, it's a level 2 assessment where you can collect an unknown sample and understand whether it has endocrine potential, whether it is showing estrogen, androgen activity, thyroid disruption, glucocorticoid, and other modes of endocrine potential. And it's not only the agonistic, like it's not the estrogenic effect, but there could be some chemicals that are masking the estrogenic effect, like anti-estrogenic chemicals. So they will be also picked up by these assays. So we would be able to know the agonist and also the antagonists when conducting these sorts of screens. The effect-based tools, I think, in a non-animal testing way, has been, there is a technical report from EU in 2014, and then the in vitro, these screens are becoming part of the regulatory framework where these estrogen activity and for dioxin response kind of assays would be used, and these are effect-based tools rather than based on target chemicals. And as I said, we need to develop these screens for the fish species that are present in our environment. And Dr. Peter Bain and with our Japanese colleagues, we have been able to achieve that. Next slide, please. So as I said, that the human and fish receptors can be very different. The published paper, we talk about that if we want to look at the progesterone activity, we find that the progesterone receptor is a potent agonistic of androgen receptor, but do not activate the progesterone receptor. So these are the subtle differences, and if we want to look at the responses to the sewage effluent discharges, then these screening tools, which are complex mixtures, should also incorporate the existing in vitro assays that are based on human receptors, but also using fish receptors would be really add value. And then when you come up with a screen as it is listed in the first column based on different mode of action, estrogenicity and inhibition, and androgenicity means anti-androgenicity or dioxin-like response, or as an oxidative stress or activation of pregnant receptor, X receptor, then what do we do? So there are, you get some, you report the results in terms of equivalent of a reference compound. And for some of you, it would be complicated. But if you look on the right-hand side of this table, what we see is that these effect-based trigger values have been established based on the work that has been done in terms of linking the in vitro work with the effect on in vivo, some of the organisms. And you can say if the value is 1 to 3, then the risk is low, but if it is above 100 times, the risk is very high. So you can establish, and it has been established for estrogenicity and some of the other in vitro screens by biodetection systems, and this is being currently used as a guideline. So NZEC guidelines, they do not include non-traditional effects. So even in the revised methods, like biochemical, physiological responses are not included. So even like mutagenicity, genotoxicity is not included, but they are using this weight of evidence approach. So when we look at these in vitro assays, they are not currently part of the revision of the guideline documentation. And the thing is, because we need to develop methods for our own fish, and because fish, there are, if you look among teleost fish, there are a number of fish. Next, click please. So we have worked on murder and fish. You can complete the slide, please. And we have used as a male, female, and it is available at all over Australia. But there are other species also. So the work is not complete. There is more that needs to be done even with the fish. And we have been able to establish that the rainbow fish is quite sensitive. So similarly, if you are working in India or developing world, then labio rohita, katla, those are some of the fish species that we need to look at and establish whether they are sensitive enough, because carp is not, whether they are sensitive enough. And some countries do have zebrafish in the wild, populations are available. So then those tools can be used easily. But if we are focusing on native fish species, then there is a lot of work involving molecular biologists, chemists, and physiologists. So based on our work, based on we established, so although in the BDS is recommending 0.3 nanogram per liter as a, the trigger value, here we didn't go that far because we didn't look at very low concentration. So based on the work that we have done, we said if it is less than 1 nanogram per liter, then there is a low hazard. But if it is between 1 to 10, then moderate hazard, and greater than 10, definitely high hazard. So I think tiered risk assessment is the way to go, as we cannot analyze all chemicals one by one. So if we start on the left-hand side of this graph figure, you conduct these in vitro screen. Even if they exceed the hazard rating that has been established, either based on country by country or BDS framework provides an indication. If there is no exceedance of guideline, there is no need for testing. So if it exceeds, then it should be done by short-term study. If we find biomarker alert, then we should do, full life cycle testing, because that's the way we will be reducing resources. To do a full ecotoxicological study over, say, 28 days would be quite expensive, but in a 96 well plate, you would be able to screen a large number of samples, around 40 samples with a duplication, and still get the results that would help in deciding whether you should be focusing on this mode of action or not. And if it is endocrine disruption, whether it is estrogen, androgen, thyroid, or glucocorticoid, or other modes of action, and accordingly, then you can decide on what chemicals you should be analyzing for. So we are working with, taking a mobile fish unit. Anyone interested, please let me know. And this work was done in 2012, where we went to a wastewater treatment plant in Wodonga, set up a fish study for 28 days, and we found that there was no effect, because firstly, the treatment was good, and the second thing was that there was a great dilution. So there was only 0.2% of effluent that was getting mixed with the river water. So the risk was low. So there are a number of factors that need to take into consideration. Next slide, please.
Sorry, we got about 5 minutes to
yeah.
Yep, you're good. Thank you.
Yeah. So with the, thanks, Trevor, with the multiple lines of evidence, I think you can find out where the red signals are, and then you would know, okay, is there an issue, whether you need to consider endocrine disruption here. And estrogen has been used as a key indicator when we look at the endocrine disruption, because science is well developed. So, but also the timing of exposure is also critical when we conduct these studies. So when Dr. Bhatia, she was a PhD student. She did a lot of work with the phthalates plasticizers, and the nail polish has a lot of these phthalates. Just to let you know, ladies. And we did the study, and we found that even you need long-term study. When you do a study for over 90 days, we found that the fish were having male and female, ovaries and testes. Intersex condition was there, and based on our study, the Department of Health has used our data in environment tier 2 assessment for phthalate esters by McNess. So fish caging study, I said, is critical. We get the data, we look at, okay, the estrogenic potential by the in vitro was 10 nanogram per liter. And when we do the biomarkers using that framework, we found that there was vitellogenin induction. When we looked at the genes, they were also showing induction at the outfall. So that shows that this specific creek had a potential of, causing adverse effect in the fish inhabiting that system, and this was receiving wastewater treatment effluent. So when we look at the methods, fish sexual development methods, you can see there are methods that are developed, but they are quite expensive, and it could be run over 60 days. So I think in vitro testing definitely helps in designing studies and only conducting these kind of tests as a tier 3 or 4 assessment. And this is, again, a 2 generations test. Nowadays, we are finding more and more that the multi-generational effects of these contaminants are also critical. So there are investigations happening, multi-generational tests are being developed, and the methodologies are established where you could look at over 2 to 3 generations the effects of the low concentration of these contaminants or the effluents, and there's a lot of information on this. Okay, so I was privileged enough to be part of this endocrine disruption, pest and workshop that happened in 2016, and we talked about a lot of issues in relation to endocrine active substances. And there is a journal through CTAC, and all these papers are published. And it was great to work globally to undertake some of these issues and challenges we face when we address endocrine disrupting chemicals. And I think the main thing that I would like to highlight is that, okay, you look at bioanalytical tools as screening tools, but then there is also a need from a regulatory perspective to focus on lethal, impaired development, impaired reproduction that can lead to population responses as extinction, or recruitment or population structure. So there is a lot of gap between these two. And I think the adverse outcome pathway is a conceptual framework that was developed by Gary Ankle from US EPA and his team. And they are continuously working on this framework and to bring the linkages between a molecular initiating event and as an adverse outcome at a level of biological organization, so organism level, and then population level. And they have been quite successful, especially for organophosphate pesticides that have a specific mode of action as acetylcholinesterase inhibition, and also for endocrine disrupting chemicals. And this is just to show if there is an estradiol present, do we see vitellogenin activity? Do we see change in oocyte development? Then we would say, okay, there could be an effect. But the main thing is we need to understand the normal biology of these organisms. And the main thing is if we look at the AOP pathway, and there is enough information available on this adverse outcome pathway. So the toxicity pathways up to the cellular responses are on the left-hand side, and the regulatory endpoints, which are at organism responses and population responses, can be considered as regulatory endpoints. So toxicity pathways are high throughput, they are mechanistic, and the regulatory endpoints are guideline studies. But if you combine them together with the epidemiological and field studies, I think we will be able to answer this question. And by using high throughput approaches in tier 2 and 1 and 2 assessments, I think we will go a long way. Next slide, please. And this is the tier 1, 2, and 3 framework. And as I've said, in vitro assays are part of tier 2, and tier 3 is where you look at the effects on organ and organism level. So evaluating effects at a population scale is challenging because of time, and we don't know about the biology of our wildlife population. So I think this is the reason it will be really good to use adverse outcome pathway, linking these tiers together to be able to be part of regulatory framework, so that we can understand firstly about the chemicals that are causing these effects, and secondly about the effluent that are being discharged into the environment. Indian situation, this is very common in the developing world. I've seen it all over India, even in Myanmar. So there is an outfall, and that is discharging its waste. And this is in the dry season. Monsoon is good, everything clears up, but this is a dry condition. And what we are seeing is surfactants and foam. And when you talk to local people, they say they do not find any fish in these waters. It's because of these chemicals. We are still struggling with managing nutrients. We are still struggling with managing metals. On top of it, there are these emerging contaminants that need to be looked into, and the sources need to be tackled before it becomes a greater problem. So we have been using scorecard approach to track pollution in the river Ganga. And actually, the data that we have so far looked at is only physicochemical characteristics. And now we have got Australia-India Strategic Fund, where I'm comparing micropollutants from sewage treatment plant and their adverse effects in a South Australian environment, and comparing it in the Varanasi and Allahabad. So there is a lot to talk about, but I just wanted to flag it that there is some work happening, and it can be implemented using the same work in any part of the country or the developing world. And even in Australia, the beauty is to compare and contrast is that because some regulations or the regulatory framework is working, the effluent treatments, and we have a zero waste discharge policies in many states. So the treatment is really of a very high quality, and that's why we do not find the concentration of these contaminants. Even the in vitro responses are quite low. For estradiol, it's mostly around 0.2 or 0.3 nanogram per liter. In compared to the Indian condition, it could be 10 or 50 nanogram per liter. So I think that gives us, as a researcher and as stakeholders, to be involved in and comparing and looking at the tipping points in these two systems. So I think this one is a good slide because it talks about the integrated monitoring in the terms of hazard identification. So I've talked about different tiers. This tier assessment talks about the routine chemistry, general toxicity, specific toxicity. You can combine them all together by looking at their criteria, looking at their trigger values. If the responses of all these three are greater than their trigger values or threshold value, then the risk is high. And what we need to do is come up, or there are tier 2 assessments in chemistry, also in toxicology, like the adverse outcome pathway, and in the biological field also, that can be implemented. So these act as traffic light. I was talking about that scorecard, and the scorecard approach can be used even for the endocrine disrupting chemicals in any environment. So there are other modes of action. Glucocorticoids, you all know prednisolone. So we need to look at some of the other compounds, and we have found them in our environment. We know, so Dr. Bal, she was a PhD student. She did some fish studies and found osteoporosis-like symptoms when these fish are at early life stages are exposed. And then she conducted multi-generational study, and she found that shell of these snails were getting thin, and the effects on the water fleas were at environmentally relevant concentrations. And we are picking up glucocorticoid activity in our rivers here in Australia. So there are a lot of challenges, complex systems, multiple modes of actions, limited scientific resources, and international research programs provide guidance on what's happening. But I think the collaboration is the way for sharing information caused by endocrine disruption and learning from each other. So the recommendation is, yes, endocrine disruption is quite a scary issue, but I think using in vitro as using tiered assessment where you use in vitro based assays, I think we can predict some of the effects, and adverse outcome pathway, developing those cause adverse effect linkages is critical at population level. And some work is happening, but there is more that needs to be done, and especially about even thyroid disruption, our frog species, amphibians, because the metamorphosis is a stage where thyroid hormone is critical in frogs. And if there is thyroid disruption, then we need to monitor that. Okay, so we are having What's in Our Water Conference symposium, and most of you would know about it. It's on 30th October to 1st of November in Canberra. Please join us and check the website. And thank you for listening to me. There is a lot I would like to share, but with the limited time, I've just given you an outline and overview. And I would like to thank all my team and all the PhD students and all the funders who have been with me through this journey over the last 15 years. Thanks a lot.
Thank you very much, Anu. That you would get the champion award for having that much. It's a feast. No kidding. I really appreciate it. We all do. A huge amount of work gone into that, and it just reflects the vast experience over the last 20, 30 years for yourself. Thanks so much for this, and it's been huge. Obviously, you're not going to take all that in 1 hour, but look, the PDF will be available. Just to give us a yell. You want a copy of that? Look, I would really love to deal at least with one of these questions from Basant and maybe one of the others as well.
Sure.
So thank you everyone for upvoting your questions. That has been very helpful in terms of picking the right questions here. There's a few of them on the board. Basant says, Anuji, very informative and interesting presentation. Do you have any thoughts on whether the problem of endocrine disruptors are more in developed countries compared to the developing countries, due to the use of the variety of products used?
Very good question. In the same percentage, it's I think if you look at the use of the plastics in the developing world now, and the waste that we are creating, I think maybe 20 years ago, this issue was probably was not of that much of concern. But as the urban population, I think the population density that we have in these countries, living closer to the river and relying on river for everything, is leading probably the chemicals that are causing impacts in the developing world and the contaminants that are responsible for endocrine disruption in the developed world could be different. But I think the level of an issue, I think we need a national level or a global level monitoring studies. But there could be some predictions could be done in terms of the usage. But what I see is the usage of pesticides in agriculture area. It wasn't there when I was growing up. The usage of plastics, the usage of packaged material. So I think all these are leading, and we need stricter regulations. So until these regulations are being implemented, it's very difficult to say. And also the treatment plants, 25% only, the population is connected with the sewage treatment plants. We are talking about Swachh Bharat, Clean India, but I think there are still issues. What do we do with that liquid waste? And what about the solid waste that we are generating by having toilets? So I think it's that vicious cycle. We need to be looking at more carefully, and it becomes a country-specific question also, or a state-specific question, depending on whether you're in a dry climate or in a monsoon area. So yeah, would love to discuss this with you further.
I'm so grateful to you and Anu, but for one, and also there's been a bit of a team work to make this happen today from Michelle Ha, our marketing communications manager here at iSwarm, and also Joel Vortman working here with me right now on all the logistics and the directions we take here. So thanks to those two and others here in the team here at iSwarm have made this come about. Most of all, thank you to everyone for attending, and to you, Anu, Dr. Anu Kumar, for your time and effort on this incredibly important topic of endocrine disruptors. For now, we'll call it a day, shall we?
Thank you very much. Thanks, Trevor, and thanks, iSwarm, for letting me share.
It's been a great pleasure.
Experience. Thank you.
Very enjoyable. Thank you, Anu.
Thank you.
See you again, everyone. Bye.
Bye.
Subscribe to this YouTube channel by clicking the subscription button. For future webinars and online short courses, please visit our website at australianwaterschool.com.au.